Okay, good morning everyone and welcome to the Anjon Bremer Halo webinar hosted by Reha Care and Head to Foot Orthotics. Just to give you an idea of our relationship with Reha Care and Head to Foot will be the distributors and will support, the Anjon Bremer will be distributed and supported by Head to Foot Orthotics via Anjon's agent Reha Care. So Head to Foot will provide you with clinically orientated product and support, and Reha Care will be the vendors for it. So today's webinar will be split into two parts. So part A will be the exploration and key features and nuances of the Anjon Bremer Halo system, presented by Ian Cutts, who is one of the specialists at Anjon Bremer. You can see him waving there. And part B is going to be a fitting demonstration, and that will be facilitated by Steve Dickins here, who is one of the directors and clinician at Head to Foot Orthotics. Questions, if you have any questions, please post them in the chat and we will address them during this webinar. So we'll keep an eye on the chat, and if any questions, just pop them in the chat and they'll be addressed as we go, okay? I think everyone's muted their mic, so if you haven't, please do so. And we will get started. So Ian, you'll be able to share your screen for your presentation, so I'll hand over to you.
Thank you, Steve. Good morning, everybody. I'm a Brit living in America, and part of my life is commercializing Bremer Halo around the world. So pleased to have a chance to talk to you down there in Australia and I think New Zealand. So I'm going to go to, you can see. Just bear with me 1 second, sorry about this. The Bremer, can you everybody see that?
No.
Steve?
Not yet, Ian.
Nobody? Okay. Hold on. Can you see it now?
Yeah.
All right, cool. So the Bremer Halo has been a device in the orthotic and neuro-ortho space for about 40 years, developed by Ross Bremer back in the late 1980s. And Anjon Holdings is the manufacturer of the product and has been ever since it started. And for a good few years, it was contract manufacturing the device for J&J, for Depew, part of J&J, who had the system up until 2018. So now we're basically commercializing it directly ourselves. And obviously with Australia, we've had the TGA registration since beginning of this year. And the device itself is the same as was previously available through Depew. So some new label benefits. It is compatible with both 1.5 and 3 Tesla MRI. There are two versions of the Bremer Halo. One is a fully sterile, which is a gamma irradiated ring, crown and pin items, and they have a 35-month shelf life at manufacture. Or we also have the same version clean, but requiring a autoclave steam sterilized. We've got the same items in two formats. But I think for Australia, we're focusing more on the fully sterile available parts. So the product is broken down into a number of components. We'll talk about crowns and rings, they're the cranial parts, skull pins, torque limitation, and vest. So in the Halo crown, and this is the most regularly used adult cranial component in the Bremer range, there are two sizes providing you with a range from 48 to 66 centimeters head circumference at the equator. And the crown design, unlike a ring that you may have had with OSA or you may know from the PMT range, the crown is on two latitudes. So your anterior
for the extra days, I'm always like, there's so much I want to do, and then I end up doing none of it.
Sorry, could you please?
Are in the sort of safe zone above the eye, and then the two rear pins are sort of seated in that hard bone behind the ear. So this is quite important for maintaining the crown position when there's upward force on the crown component, which could be when you've got the vest on and you're upright ambulating somebody inside that construct. So it helps to reduce the risk of any upward movement of the crown and the pins on the skull. The other thing is you've also got an intact design with the crown. So biomechanically, it's an extremely rigid construct, and it allows access to the back of the head. So if you can compare that with an open back ring, then there's maybe slightly less biomechanical rigidity in the open back ring compared with a crown design. All the adult crowns and the rings come. They have positioning pads for the correct placement of the crown component, and there are torque limiters which go onto the skull pins, and we'll talk about those in a minute. Now, Anjon also has an item that Johnson & Johnson used to call 3D crown. This is a composite material as opposed to a metal alloy, which the standard crown is. It's exactly the same design, but it has adjustability in these rear pegs. So with one part, you can cover 48 to 66 centimeter head circumference. And it has a slightly different anterior pin placement because you have like a slider part that can move on this bar to get the correct positioning of the two anterior pins. And these clamp down so the pin is rigid. And then the rear part is the same as in the standard crown. You put the skull pin through that. It's in sizes from 43 to 58 and 53 to 66 centimeters. So again, covering the majority of your adult head size patients. And then for kids, there are two pediatric rings. These are a composite material. With the children, you use more skull pins, so generally 8. So it comes with 10 pins. Now they're the same, these pins are the same as the standard Bremer pin in the adult crown and ring products. And then the most important thing with the children is that there are no torque limiters supplied with the pins, because you're going to be setting a torque level less than 8 pounds/inch. So that would be determined by the surgeon overseeing the case. So you'll need to use some form of wearing this ring. So going to skull pins, on the left-hand side, you can see two designs. The standard Bremer pin is this one on the furthest left, and it has a sharp conical tip. And then there's a slightly longer product called a cutting tip pin. This used to be known by J&J as a high fix pin. And the difference, it's slightly longer, a couple of millimeters longer, but it has a more aggressive bite from its point. So the biomechanical benefit of this is it should maintain the torque position over time. So one of the things that seems to happen with skull pins if they're in for, say, 8 weeks or 12 weeks, which could be the life of a halo vest, then they can loosen over time, but more tight form through the life of the halo. The diameter, etc., is exactly the same as a standard pin. So these two are sort of these two can be swapped over. You can use one or the other. And then we have a metal torque limiter. This is in titanium. Used to be red plastic in the past years, but the plastic material was sterilized with ethylene oxide. And when Anjon went through its own process to get a sterile version of the system, the ethylene oxide is not so available as it was. So gamma irradiation is used, and we found the plastic was degrading. So we moved to a titanium snap-off cap. Does exactly what the red plastic ones used to do. Basically, this goes on the end of a pin, and when it's tightened, it will break. First two tightenings of the skull pins can be done with the 8 torque limiters that are in the set, working on the basis that you're only using 4 of the 5 skull pins. Now, we also supply a permanent torque driver. This is something that you should have with every halo set in your hospitals, on your halo cart, or wherever you've got your kit. And this is able to be set at different torque levels from 1 to 8 pounds inch. We also have that down at the bottom right-hand side, an item which, if you've got your own torque limiters already, you can use to be able to connect your torque limiter to the Bremer pins, and that's the torque driver set. So it's exactly the same component as here, but we sell that one separately. And I know that fits into OSA torque drivers. Not exactly sure with the PMT ones, but definitely it fits into OSA ones. Now, with for adult halo crown or ring comes with a traction bale. This is an aluminum part, or aluminium, as we say in England. And that fits into any of the Bremer cranial parts and can then be attached to the traction set that is maybe being used on the patient. And then we have a universal table adapter, which is both anterior and posterior approach, and that will work with any of the Bremer cranial parts. So the pediatric rings, the adult rings, and both versions of the adult crowns. So that, again, at the hospital level is an important part to have, as it will allow you to fit the crown or the ring and attach it to the surgical table. Now, in the Bremer range, when you move to a complete halo vest, and the plastic material is a cold flow plastic, so it can be cut. It can have holes made in it. So if you've got polytrauma patients or whatever, where you maybe need to take account of lines or whatever coming out the body, then this can be somewhat customized. All our vests are supplied with a mock lamb's wool liner, and there are additional liners available for any of the items which you might need, obviously, in hot and humid circumstances like you do get in Australia. The other point is the superstructure on any Bremer vest. So the uprights, the lateral bars are able to be connected to any of the cranial components. So any size Bremer vest will fit any size Bremer cranial part: pediatric ring, adult crown, or the 3D crown, adjustable, sorry, the molded crown. And then we have another vest, which is a light vest. This is a hard plastic. there's less coverage with the light vest. It's a bit more similar to the OSA vest, whereas the classic vest is more similar to the PMT vest. So this one you can't cut or do anything to. It's designed to float on the muscle bodies in the torso. And again, you know, having less coverage, it's going to reduce possible issues like pressure points or whatever that might cause wounds, and just general comfort for the patient. So we sell probably about 50% of our vests are the 2 light vests, and then the other 50% are the 4 classic vests, and the 2 middle sizes . And then for kids, there are 2 pediatric vests in a similar material to the classic vest. So one final part before I finish is CPR. So if you need to do a CPR access to the chest of the patient, then the 2 attachments for the anterior superstructure have to be loosened a bit, the waist strap undone, and then the front of the anterior vest is lifted up to allow you access to the chest. So this is different to the PMT and the OSA devices. So a key thing to have available all the time is the black wrench. This is the main tool that will work with all the nut requirements on the Bremer system, both on the cranial parts, the pins, and also the vest attachments. So it's a very, very important universal tool. So what we do recommend is that is taped, that wrench is taped onto one of the uprights, if the patient's in the ITU, for example, so that when an episode might need to be done with CPR, then they've got access to that wrench and they can get the 2 positioning locking points on the anterior part of the vest loosened. So that's it from me. I'll be happy to take any questions that there may be.
Any questions, Marco?
Any questions at all after that? Jared, I think you may be typing something. So any questions, please do type it in. Thanks, Anna. And what torque would you use for pediatric crown ring?
Yeah, I think the surgeons are going to determine that, and again, it comes down to their own individual choice, but they're usually low, aren't they, in the sort of 3-4 pounds range, maybe slightly higher, 5 or something. So I know it is a surgeon preference or protocol to the hospital to set the torque level for the kids. So there isn't really a sort of straight answer, Steve. I think it comes down to the
Surgeon's preference.
Individual surgeon preference or protocol.
Sure. And just following from that, in the slide showing the light vest showed both short and tall versions of 5
foot. Tall light vest is for taller patients.
Yeah. And as a standard choice, we typically would use the light vests.
Yeah, well, if you look at all our sales, you know, if you look at the whole worldwide sales, we sell around 50% of the adult vests are the light vest short and the light vest tall. And then in the classic range, as I was saying, makes up the other 50%, but there's 4 sizes in there. So again, I think a lot of this comes down to institutional preference, probably for Australia, because you're hot and pretty humid in many parts of the country, then the light vest is probably more suitable. And I think it's a bit more like the OSA system that you've had in the past. So again, it's more in line with what people are used to. Like I was saying before, the classic vest looks more like a PMT vest. So there's more coverage with those, so you may get more perspiration. And, again, I think it will come back down to orthotist and surgeon preferences, at the facility level.
The waist straps on the vest are all the same length?
Yeah, there's some additional waist straps. Classic is around 50. There's two sizes in the classic. There's a 56 and a 38. And then there's an extra long waist strap for the light vest. So it depends on the actual size, girth size of the item, but we can send to everybody a sizing chart, that will give the vests and the strap sizes to those vests, and then also the replacement items that you might need to get.
Sure, Jared, in terms of the correct height for the light vest, be 5'9" and above.
Yeah. Again, I'll send you I've got a sort of like a summary overview that I can send for everybody, which has got the vest illustrations and size correlations. So I can forward that on after the webinar.
Just another one, Ian. What tool do you use for pin removal?
Right, they never use a screwdriver. You can use a small coin. So in America, they'll use something like a 10-cent coin, like a dime, as they call them here. So you just put that in and then twist it, because obviously you're concerned about the driver going out of the groove in the pin and maybe injuring the patient. So it's pretty simple. And as I was saying before, I think when these halo crowns are on for a long time, the pins do get a little bit looser, so they are easier to undo. Obviously, the lock nut needs to be loosened as far as you can, so it's easy withdrawal of the pin, but it is pretty straightforward. So a small coin is definitely the preferred method to start it with.
So this is the torque driver that you can use for the pediatric ring as well. It goes right down to 2 pounds.
As long as it's mature skull bone,
yeah,
and there's no compromise to it, then it's always 8 pounds inch. If it's osteoporotic or there's some other factor, then again, the surgeon is going to set the torque level that they think is appropriate to that patient's situation.
Are there recommended retention intervals for the Bremer system?
Can you say again, Steve? Sorry.
Is there a recommended retensioning interval for the Bremer?
Yeah, well, there's the first tensioning, and then a period of time after it should be tightened. Obviously, it should be tightened before any traction is applied, and or a vest is going to be applied. So you've got at least 2 tensionings, as far as I'm aware, in the initial period, of the halo being fitted, prior to something else occurring, either connection to a traction or fitting that halo part to a vest. And then periodically, I think it will come after that. It's going to come down to your oversight as care providers, isn't it, to that patient, and how those skull pins are maintaining their correct torque.
Correct. Well, thanks, Ian. Now we might move down into part B now, guys. And can please do type in your questions, and we will continue to answer them as we go through. But we'll move on to part B now, and part B is going to be presented by Stephen Dickins. So I will hand over to Steve now, and we'll go from there. Thank you.
Well, good morning, everybody. I'm Steve, another Steve. Thanks for coming into our webinar today. It's lovely to meet you and hear your questions and talk through the Anjon Bremer system. Today, we're going to be talking a little bit about the application procedure, the main steps to the application procedure, and really just to let you know that everybody does things slightly different when it comes to application, but this system is not really that much different from the OSA system that you've probably been using for some time. I'm going to make a couple of caveats over what we're doing today. The first one, we've got our client lying here, Liam. Now, what we've done is to put a swimming cap on Liam's head so that you can see things reasonably well, but obviously we're not going to be putting pins into Liam's head today. So we're going to be using the positioning pins, and we're going to have quite a number of them around his head to try and maintain the ring in position. But today's more about fitting up the vest and showing you how the ring would be positioned, but certainly no pins into Liam today, thank goodness. The second thing that I'm going to say is that we've already got a headboard in situ. The reason that I use a headboard is to give us good circumferential opportunity to get to the head. We're going to leave this one in situ the whole time. And the reason for this is normally once the ring is positioned and it's been pinned in, when the patient's either log rolled or flexed to get the posterior vest in, the headboard is removed. We're not going to do that now because the headboard's difficult to remove when the ring is not attached very securely to the head. So we're going to leave the headboard in situ. So you'll see that the posterior vest is already in position. So today we're going to be fitting the Anjon Bremer light vest. So this is the light vest that Ian was speaking about. It comes in a standard size, what we call a short size and a tall size. Liam's about 6 foot tall, so he's going to go into a tall Bremer light vest. And as you can see, it's quite a light setup compared to, as Ian was speaking about earlier, this is the system that we use for the classic vest. So the classic vest has a lot more material and it can be cut away if you've got patient anatomical issues. This one's very similar to OSA, so that's what we're going to use for today. We'll put that one aside for a moment. This is the standard Bremer crown, and as you can see, it's a little bit different from what you may be used to. It's an open back design, but it does have these posterior diving sections that do allow you to get the pins under the greatest circumference to stop any sort of superior dislocation. I've put one of the transverse bars in place already just to make it a little bit shorter to do the fitting. And as you can see, there's quite a number of these positioning pins in place. Normally when you get this crown, you have one positioning pin right in the middle, 2 at the back, and this middle one allows you to line it up with the nose really quite well. So the first thing we'd be doing is we'd have the patient supine, we'd have them possibly sedated, and we would also have them in the headboard. You don't need to use a headboard, but I use a headboard pretty well every single time, and you can buy the headboards as part of the range. So the first thing we'd be doing, I hold the crown. It means that your fingers are not sitting around the crown, the capital arch, that's what I hold on to. And the great thing about the capital arch is it really does give you the ability to position the ring on the patient's anatomy really quite well. So the first thing I'll do is line it up with the nose, if everything's symmetrical with the client, which we hope it will be. And then I'll start using the positioning pins just to set things up in a position that is really quite symmetrical for the client. Now, at this point, you probably will have shaved the posterior pin sites to ensure that you've got clear access without any hair in the way. And the way that you can figure out the area to shave is to just put the ring on for a moment, check where you're going to put your pins in, take the ring away, shave it and go from there. And at the same time, some surgeons will actually put the local anaesthetic in at that same point. Other surgeons will wait, and they will ensure that the pin positions are going to be just right by ensuring that the ring has been set up in exactly the way it should be before they worry about putting the local anaesthetic in. So we're not here today to get everything absolutely perfect, remembering that we want to have the pins generally on the lateral third of the eyebrow, about 0.5 centimetre above the eyebrow, but ultimately this comes down to surgeon preference. The main thing we want to do is make sure that there's not any pressure over the ears, and we want to make sure that these posterior pin sites are below the greatest circumference to stop that superior dislocation. It's one of the lovely things about the Bremer system. This could probably sit a little bit lower, but at this point I'm not going to worry. Just to give you an overview, this is sitting pretty well on Liam's head. So at this point, it's a matter of getting the local in and then grabbing the pins. Now, normally you and the surgeon will actually figure out where the pins are going to go, make sure that the locking nuts on the pins are pulled right away. And generally you put 4 pins in for an adult, possibly 6 if you want a little bit better hold or they've got some sort of compromised bone integrity. And at this point, we put all the pins in, and then if you have the ability to, I generally do up the pins equal and opposite. So I'll give a few turns, anterior right, posterior left, and then I'll go equal and opposite. And I'll continue to turn those gently while I'm checking the ring on the patient's head until we start making some contact with the skin with those pins. Once you're doubly sure that that ring is in good position, it's now a matter of screwing home, going diagonal to those pins to ensure that you've now got a reasonably well seated and secure ring. It won't be done up more than finger tight at this point. So this is the point I would suggest that you just pop around, you make sure that everything's looking reasonably symmetrical, and we're not 100% symmetrical here, but that's not the issue for today. And once everything's looking good, then it's a matter of really screwing these pins home as firmly as you can, finger tight. Now, these are the little torque caps. These torque caps, these limiting caps will snap off at 8 pounds per square inch. So once you can no longer do the pins up anymore, it's a matter of just popping these torque caps on the top of the pin and diagonally doing them up. Eventually these will shear off, and once they have, we know that those pins are in the skull at about 8 pound inch. The good thing about that is you can remove them. You can then tighten up the locking nuts. Once you've done that, the ring is stable on the patient's anatomy. Then it's a matter of removing all the positioning pins. These often get left and they can sometimes cause issues with skin, so make sure you take those off. And at that point, the registrar or surgeon can now hold the ring. They don't have to worry as much about the head positioning board. So we'll just take these out to make sure that they don't cause Liam any troubles. Now this is the point at which we've got a stable ring on head. Double check and make sure everything's good. If it is, we can continue ahead. At this point, if you do want to use the traction hoop, you can certainly attach the traction hoop depending on where the patient sits in bed. And the traction hoop generally gets attached at the point where the capital crown meets, the capital arch meets the crown itself. They're not generally used on this knurl piece, which is where the transverse bar attaches. Okay, next part. Attaching the transverse bar. Now the transverse bar is what attaches the halo ring to the vertical superstructure. Now the transverse bar can be attached either superior to the ring or below the ring, depending on what you want to do. At this point, we're going to attach it above the ring, and that you've got a serrated edge. Those serrated edges just need to be brought together. And you'll find with an aluminium ring, you don't get as much chance of cross-threading compared to some of the OSSA product. And the other thing that we want to do here, guys, is make sure that the transverse bar is reasonably, well, quite symmetrical and parallel to the actual ring itself. And the reason for that is later on, if you want to make adjustments, you want everything to be symmetrical on both sides. I've already positioned the bar on the other side, the transverse bar, and we're in reasonable good position here. So at the moment we have a ring on and we have the 2 transverse bars in situ. I would now just take a minute to ensure that those transverse bars are symmetrical. which they are, pretty close to being symmetrical. And then I tighten them up to make sure the transverse bars don't slide backwards and forwards on the ring. Okay, so they're up nice and firm there. This gives great holding points for the doctor or nurse, or whoever's holding the head, or whether it's another clinician. Everything's in position. We've got a good stable ring on head. At this point, we've got two options. We can either flex the patient forward. I don't know if you want to put that one back. We can flex the patient forward, or we can actually log roll them. With the patient head being held, the surgeon does the rolling count, do the roll, do the flex, remove the headboard, and then it's a matter of sliding the posterior vest into position. So this posterior vest has already been slid into position. The uprights are just hanging out the back here. What you want to look for is you want to make sure that the top of the vest sits at about level C7, and the little angulation parts are just going to sit flush on the trapezius. We don't want too much pressure. Make sure the client's got their eyes closed throughout the whole process, and make sure they've got their shoulders relaxed. If they're not sedated, they'll really pull their shoulders up nice and tight, and that's not going to be very good when you're actually relaxing them. They're going to get all this opening across their shoulder straps. I make sure that to get the symmetry of the posterior shell or the posterior vest, make sure that these straps pull up about the same amount from either side. Now, this is if the client's symmetrical. If they've got some sort of huge scoliosis or there's some other issue, you're just going to have to take that into account. The other thing that I do at this point, before I've attached anything at all, I actually take the anterior vest and I place the anterior vest on the patient, and I do up. This is a little bit different from some. I do up the vest itself, and the reason I do this is to make sure that strap sits about xiphoid level, but also to ensure for females, their bust is going to sit in the right section here. And it also allows me at this point to just make sure I'm going to have enough upright height for someone who's potentially very tall. If I don't have enough upright height, I've got the option of moving the transverse bar the other way. And if these little these attachments to the vest are one way, they're up on the top high side at the moment, but they may be attached on the low side, you can always twist those around to give you some more height. But at this point, I can see that everything's going to sit reasonably well, so I can just leave that alone. I will also, though, just gently do up the over shoulder straps primarily to get them out of the way at this point, because the next thing we want to do is attach the posterior uprights to the transverse bar to ensure that we're starting to get some stability and basically put the Meccano set together, which is the frame of the halo. So we're just going to pull those out of the way for the moment. Okay, so we've got our little wrench. And if I come around here, I'll try and do it so that Steve can still see. We've got our universal nut here. You can also see that the posterior upright is not being put on too tightly. So I have the ability to adjust that posterior upright's angle on the posterior vest. And it's just now a matter of attaching that universal joint to the posterior section of the transverse bar. We want a little bit of transverse bar hanging out the back, but not much at all, because we want to have a big square frame as best we can. And then I firm this home, and we're starting to get some stability on that posterior side. We just have to do this equal and opposite on the other side. And if you've got someone to help you, so much the better. Even if you can get someone, a nurse or somebody to help you, that'll work quite well for you. Okay, so at this point, we've got a degree of posterior stability. You'll also notice that these little knurled nuts here, these threaded nuts are well out of the way. These are designed to give you the option to give some distraction if you need to down the track. So at the moment, we've got the posterior upright set reasonably well. Quite simply now, it's a matter of bringing the anterior upright over and just playing with the heights to make sure that that's going to work well. And you'll notice I've got these done up firmly initially, but you also need to make sure that all attachments are nice and flexible so that everything goes on with zero tension. It's one thing we don't want, guys. We don't want tension in the system. And the reason that these Bremers work so well is that they have this massive amount of flexibility that's quite simple. We're just getting to the point now where things are looking pretty good, but making sure we're not putting anything under tension as well. Okay, there we go. So at this point, what I normally do is I check and make sure everything's looking pretty good, and then I provide a little bit of chest compression. Now I'm doing this on my own, but a little bit of chest compression, and then I will do up, thanks Steve, the universal upright at the top, and firm that home, and then the anterior upright attachment on the vest. I'll do exactly the same thing at that point. Again, nice and firm. I've got an extra hand now, but I'll get Stevie J to do the same thing. Thank you. Start up at the universal joint first. And then with that anteriorly directed pressure, we can do up the attachment to the anterior uprights as well. Okay, last thing we want to do is make sure Lean's shoulders are nice and relaxed. Hopefully at this point, as we get towards the end of it, they will be. We can do up these over shoulder straps a little more firmly, and then we can go back down and adjust the circumferential strap around the chest. At this point, it's in pretty good position and he's looking pretty good. So at this point, the next thing that you'd want to do is either roll him or flex him and do up the posterior upright attachments, which are actually still loose at this point. So we must make sure we do that. Don't forget about what you can't see. And then I would go through and do up everything that you possibly can to make sure it's nice and firm. And at that point, you've got a patient who's stable in their halo. Just a quick one, CPR. Ian spoke about it. What happens if we need to get to the chest in CPR? Quite simply, the first thing you want to do is to remove the chest strap and then undo, with the patient lying supine, of course, undo the anterior shell, the anterior attachments, and we have really good chest wall. The great thing about this system compared to the OSA is it doesn't have a perforation here, which means that you don't get to the bottom of to the top of the chest. This way you've got really good chest exposure and the opportunity to do your CPR. We'll just pop this one back down. The other thing that's worth noting is with these light vests, posteriorly on the light vest, you can adjust the circumference of the strap. They've got numbers on the back that correspond to the circumference of the patient's chest. At this page, at this point, I should say, everything's pretty good. He's in good position. He's stable. In theory, you can sit up, you can get an II, and you can do the adjustments if you need to there. So in terms of the distraction, we've got a question about distraction. Well, you can get as much distraction as you need depending on where the transverse bar attaches to the upright. Obviously, if the transverse bar attaches low on the upright, you've got more opportunity for distraction. If it finishes very high, you'll have less opportunity for distraction. But the general idea is it's a matter of doing this both. If you just want to do it at the front, you have to undo the back section and the front section, and then just quite simply by undoing this one, not too far, you'll actually hear it click up as you distract it. Well, actually, it's not going to click for me at the moment, but you can actually see through here that I'm now starting in theory to get some distraction. That'll only work though if you've got the over shoulder straps up nice and firmly, so you've got something to push against. In terms of how much distraction, it's a bit of a hard question. It really depends on how much is required. If I required more distraction for Liam and I was running out, what I may have to do is reseat this transverse bar on the underside so that the transverse bar was coming across the uprights at this point, and then I'd be able to push his head up even further. But generally what you want to do is modify flexion extension, possibly some translation. And if you spend some time making sure your transverse bar is parallel, you should be pretty good to go. So at that point, things are ready to go. I don't think I need to tell you too much about it, but if you've certainly got any questions about the fitting, let us know. The last thing I will say, if you do have a patient that's got asymmetry in their anatomy, you do have the ability of using the classic vest, which comes in 4 sizes, heat moldable, cuttable polyethylene, as opposed to this harder nylon on the light version. I'll pass it back to Steve. Thank you.
Thank you, Steve.
I'll just get you to stay there.
Any questions at all, guys? Any more questions? There's front upright. The front upright, would you clear it behind the eye level to prevent peripheral view obstruction?
It's an interesting question, and the answer is you certainly can if that's a major issue. And one of the options you've got there, I suppose, is what I'll do it for you right now. So I've undone this piece here, and I've undone here. You could, in theory, bring that back, but as soon as you do, see how you lose the open square, which gives you more stability. It's a little bit like having the posterior bar and the anterior vertical uprights all coming to the point at which the transverse bar attaches to the ring. There's just not as much stability as if it was a big open square like it is here. So my suggestion is you've got to make that call depending on the client's issues. The other thing that you could do is transfer the transverse bar more posteriorly. But again, what we're really after is a big open square that gives maximum stability and not coming to a point like a triangle.
Pin locking nuts are tightened by fingers only.
No, so when you've got the pin locking nuts on, guys, I'll show you a pin here. The suggestion is that once the pin, you've got your locking nut, you use the same wrench. This is one of the great things about this system. You only need one wrench and you do it up nice and firmly with your wrench. Is there a torque setting? No, there's not. But with a glass composite ring, the tighter that you do up that nut, it's actually been shown that it pulls the pin back out of the skull. Whereas with an aluminium ring, which is what we've got here, an alloy ring, you can do it up quite firmly and it won't draw the pin out. Just remember too, guys, that when you do actually open up your pin set, you do get an extra 4 torque limiting caps. So instead of you giving your surgeon or registrar your expensive torque driver, they can just keep these 4 pins, these torque limiting caps available, and all they need to do is to, of course, the first thing that they want to do, sorry, Steve, is that they need to release the locking nut. If you're trying to increase the tension on the pin and the locking nut's down, nothing will happen. So you have to release the locking nut, then you put your torque limiting nut, cap on, and then 24 to 48 hours time, you just snap it off again. And then you need to put this one back down. I'm not getting Liam there, good. Obviously there'll be a bit more, there'll be a bit less thread than what I've got to deal with here. And then, oops, there's no tension on this pin, so. And then there we go, you can feel it tightening off there. But remember, some of the registrars will come in and say, let's tighten it up. They'll put this on top and go whack and it'll whip straight off because it's got the locking nut in situ. Just make sure you don't do that.
Any other questions, guys? Could you show how to adjust deflection and extension?
Sure. Okay. Good question. Again, guys, it's just a little bit difficult to do with Liam because he hasn't got his ring on in real stability. Capital flexion and extension primarily is done through this point here. The general idea is if you can undo this on both sides, I'll try and do it, but I think the ring's going to move around and potentially dislodge a little bit. If all you want to do is get flexion, more flexion in capital flexion or extension, how can I do this? Normally you just grab the ring, of course, but can you sort of see Can you see the ring moving into more flexion? Hopefully you can. And opposite, if you want to give it a little bit more extension, you can do it through that point as well. You don't have to undo anything else at all. If you want to translate the head forward or back, what you'll need to do is undo, we'll do this one back up. You want to undo this nut here on both sides, and it allows, this is why the symmetrical setup is so important. It allows the whole ring to move posteriorly or anteriorly. And if you want to get rotation, you have to undo these as well. And you can slide one transverse bar forward a little bit and one back. Otherwise, you're going to have to start doing some more major adjustments down through the attachment points to allow huge amounts. But that's not normally something people do. It's just generally flexion, extension, and translation that you're after generally.
In the case of using the ring, what is the method used to interchange the longer bolt from the ring to the vest superstructure for connection of the vest to the ring?
Using the ring, okay. Yeah, this is a good question. So I'll just, here we go. I presume what's being spoken about here is the ring. So this is the closed ring, the closed back ring that's available as well. And the interesting thing about this closed back ring is it's called the adjustable ring and comes in two sizes. So the general idea here is that once you've actually attached the ring as you normally would, the ring has 4 nuts, if you like, that hold the ring because it's adjustable in its AP circumference, in its AP dimension. These 2 bolts hold the ring secure and stable. What you have to do is actually undo one of those bolts to actually allow passing through the long threaded nut that attaches to the piece that goes onto the transverse bar. So at that point, you've only got sort of the 75% stability circumferentially. It's not an issue. You only do one at a time though. You definitely don't undo both sides at once. So out of the 4 pins that are done up to hold the structural integrity of the ring, at all times 3 of those pins are in situ and are stable.
Just going to switch the camera back.
I think one of the other things I'll just say too, guys, if you ever, and we've done this with a couple of clients, if you're ever about to fit a halo and you just want a quick run through, or conversely, if you're halfway through fitting one and something goes a bit south, ring Steve or I or Tim, just jump on the phone, do a FaceTime. We can generally help you out on the spot. There'll be somebody available if need be. We've just got one last question here about personal preference for the ring. Just a little bit of history. Australian Orthotic Technologies historically brought the OSSA Halo system to Australia. Before that, I used to fit lots of these Bremer systems. I actually quite like the Bremer system because it has that posterior drop off on the ring, so the chance of dislodgement decreases substantially. And one of the big issues between the Bremer system moving to the OSSA system, that we had a lot of clients who didn't change their processes, and they had a lot of superior distraction of the ring very soon after they moved from this system to the OSSA system. So that's just worth noting. You do have to angle your closed back ring a little bit if you want to decrease that distraction. Whereas with this option here, it's already been done for you. And as Ian said, it's a very, very stiff construct because of this capital arch. So you don't lose any stiffness as a result of no posterior piece. It's also good if you want to get to the posterior section of the head as well for whatever reason.
I think there's one last one here, Steve. When you open the ring, you loosen the screw diagonally, or does that doesn't matter? So I think that's for the adjustable ring. Is that right, Zach? Is that
not exactly sure what's happening, what that when you open the ring, you lose the screw diagonal, or does that not matter? In theory, I've not used it. I must say I've never applied an adjustable ring before. But if the other three nuts are really tight and really stable, and they've got a really, really good hold, the answer is you shouldn't have any issue in that regard. Do you want to comment on that, Ian?
Yeah, can you just walk me back? I was just looking at Jackie's question. I'm sorry, Steve, I missed what you were saying. Could you just recap what you wanted me to say?
Oh, look, it's probably been answered. Don't worry. Move on to Jackie's question if you want to. Here's the just FYI, everybody. Here's the this is the pediatric ring setup.
Yeah, well, you need more skull pins, right? So you could put in 8 skull pins in that as opposed to 4 in an adult. So that's the reason why there isn't a crown design for the children. And also the skull might be immature. So you've got issues, haven't you, with the formation of bone in the skull in a younger person. So more pins and lower torque levels. So question came up earlier when I was giving that monologue. It's 5-inch pounds generally for kids over 4 years of age. And if they're younger, then I think there seems to be some sort of suggestion that you do the pound torque level to the age of the child. So if they're 2, it's 2 pounds. If they're 3, it's 3 pounds. But once they're 4 and above, then it's generally 5-inch pounds torque.
Last thing I want to say, guys, make sure the wrench that you've used to fit the halo is always attached somewhere easy to access for that CPR and for the releasing of the nuts when you're retensioning.
All right. Well, guys, this webinar is recorded, so I will make it available for you guys. We're going to have one more question from John. Are there any issues with tracking of the posterior pins as the anterior posterior pin opposition is not generally in line as with the full ring?
John, I can say historically when I've used these prior to the OSA system, the answer is no. Some would say if you've got a very, very structurally rigid ring like you do have with the Bremer system, that the most important thing is getting the pin at 90 degrees to the skull as opposed to being completely diagonally opposite each other. Depends on what you read. There's a good article from 2007 that talks about the angle of the pin directly to the skull as opposed to the diagonal nature of the pins working against each other. Did you see the question there, Reed? Have you got any comments on that?
Again, not really, Steve, because there are so many crowns used. So, if there was a fundamental design issue with it, it probably would surface. And, the preference in adult use of Bremer components is about 80% crowns, 20% rings. So there's a very, very high bias to the crown design. So it must be achieving a certain high degree of capability, to maintain its position through the time period it's actually on the patient.
Indeed.
Well, thank you, everyone. Thank you for joining us. As I said, this webinar is recorded, so I will make it available. You each will receive an email with the link, so you can watch it and show it to your colleagues who weren't able to attend. So again, thank you all for your time, Ian. Thank you for your presentation. Thank you, Steve. And any questions, if you do have one, just please email us, sales@htfo.com.au, or you can email it directly to me, stevej@htfo.com.au. Otherwise, thank you guys. We appreciate your attendance and best wishes.
Thank you, everybody. Be safe.
Bye.
COVID-free.
Bye.